Okay, hello everyone. Welcome to another design review of the day, second of three of the day. This is incremental language development for Wolfram language and probably a bunch of things that are headed for version 13.1. All right, let's start off with unique elements, aka symmetric difference.
And there's actually two functions there, unique elements and symmetric.
Yeah, they're not the same.
They're not the same function.
They are
Okay.
related. So these are something we talked
I
about.
could never remember what symmetric difference is.
Yeah,
it's the things that are not that's only in one of the sets.
Well, that's true even if there's more than two sets. We decided we would go with that as opposed to the even odd interpretation.
The even odd one is really crazy, in my opinion.
I mean, it makes sense when you're dealing with regions, but maybe less sense here.
I've got a question. I mean, why isn't it the case? If you've got a bunch of lists here, I mean, I would quite like to know which things occur. Let's see, what are you telling me? You're telling me which things occur. What is this function again? Say that, Christopher, say that again, what the definition is of things that occur in one thing, but that only occur once. Right?
Yeah, so I mean, it's sort of like you do the union of the complements in both directions. If you have two lists, I guess, right? With more lists, it's more complicated, but
right. But so
things
that occur exactly at most. Let's say, I mean, I would claim that there's a more useful function of which this is the elided case. That is, you've got a list of lists, and I want to know those elements that occur n times across all these lists. Exactly n times, and with up to, you can say up to n times across all these lists.
Where you treat the list as sets or as lists.
Why does it matter?
Because if it appears twice in a list.
Yeah, multiplicity.
I see. Well, I don't know about that. I would think you treat them as sets.
So
but I mean,
I think the thing is, though, is that as a, symmetric difference is a common set operation, which is just, the complement of the intersection. It's sort of like, I mean, if you make like the truth table of all the different possibilities, this is like a very common one that right now isn't covered.
Well, okay, but if we're going to cover that, then like union, it should be a Verogs-ish thing, not this thing that you've got here with a sublist.
Right, and that was our first question. Is the last time we looked at this, there was a bit of a push to have the first argument be a list of sets, and
let me make a suggestion. Maybe what we need is symmetric difference is just the thing that Christopher is saying is the, filling out the set of possible truth tables. Okay. And if you know what it is, you can use it. I can never remember what it is. And that thing is Verogs. But then, okay, unique elements picks out of each list those elements which are unique to that list.
Yeah, it's the union without the intersection, I think.
The question in all these things is, can anybody actually remember these functions to the point where they'll use them rather than just writing them again every time?
Well, the original name we had for unique elements was all complements, which is at least close.
I think unique elements is a little easier to understand.
I agree.
As a name.
Yeah. But now, the thing that I'm asking for is, n occurrences across a bunch of lists. Do people care about that? Is that something? Let's see. Have I used that?
Yeah, as a Boolean function analog, that comes up, yes. But here, I don't know.
Wait a minute. What do you mean by the Boolean function analog? What's the...
I'm trying to remember how it goes. There's a Boolean function that takes an n.
Does it concept like a Boolean counting function? I think
Yeah.
it's called.
Yes, that's the thing where it says how many the Boolean counting function says how many of its inputs are equal to true.
Yes.
Right.
Okay, that's the analog I'm thinking of. But I don't know that that's so important here.
It's not very well. I mean, that thing is not although it should be used for totalistic cellular automata now that I think about it, but it isn't. It is the quintessential. I wonder whether we link that to, anyway, never mind. That's a project management question. Do we link Boolean counting function to cellular automaton? We should. And do we show it in the cellular automaton documentation that totalistic cellular automata correspond to that? That's for Avery.
Got it.
Okay. So then let's see. All right, look, it seems to me, and we do have to rush a bit here because it seems to me that we should just support symmetric difference as var args, the most obvious case. Oh my gosh, the case where
So
you're
other than
saying
returning flat versus list of lists, is there a difference between unique elements and symmetric difference?
I'm not promoting the use of, I don't think unique elements is that convincing a function.
Or I wish you'd said that in the meeting where you went and green lighted it. I mean, it's not like
Okay.
I go out of my way to waste my time implementing these.
Well, fair point.
Right. Well, but can somebody actually answer my question?
I mean, the
I
use
think
case I certainly have with unique elements is I have, regularly when I'm updating unit tables or something like that, I'll have two lists of a large collections of things, and I want to know which have been removed from list A and which have been added to list B, and I end up doing complement one direction, complement the other direction.
Yeah, I've done that too.
Yeah.
Itai, was your question about the use or about var args versus list of lists?
It was about the return value.
they don't return the same thing because
Yes,
symmetric difference.
which is my question. Is the difference just the structure, or is there something in the result that's actually different?
It's
I
the
think symmetric
structural-
difference turns. Go ahead.
Yeah, symmetric difference is, I guess you could argue, the less useful, because unique elements you can flatten unique elements and get the same information if memory serves.
All right, so your point is unique elements tells you those elements unique to each of the specified lists. And given the return value, it's basically got to take lists as its input. It's got to take a list of lists as its input, not var args. I think it'd be crazy to have var args on the input because essentially it's a filter. Take my list of lists and give me only those elements of each of those lists that is unique to that list. Does that make sense?
Yeah, I think that's why we initially looked at it in that direction, but then it's
I think it's
slightly-
right. It's
yeah.
right. It should be list to list as Danny has it here. And
Right, but I think symmetric difference. Right. So
Symmetric difference is an
the
even
flat-
odd counting thing. Like, so it includes G because G is in all three of the lists, whereas unique elements would.
is it even odd or is it?
You're right.
Yes, and
Yes, I
that's
did
what you
implement it as
greenlit the
even
last
odd,
time.
Sorry. Yeah, what I said earlier was wrong.
So I think symmetric
Trust my
difference-
implementation over my memory any day.
Okay, so then what I would propose is that symmetric difference is var args and unique elements is not. And that symmetric
Okay,
difference
now,
follows.
wait,
union and
there's an
intersection.
issue. There's an issue that has to be raised. Both of these take a comparison function. And so symmetric difference, if we make it var args, that should have to become a same test option.
Same as with union and intersection.
Yeah, I'm fine with doing that.
in
I
the
just
set
wanted to
family.
point it out.
Yeah, I think
Okay.
that's fine.
Okay.
And I do think for these functions that take a comparison as an argument, I think as a courtesy, we should probably support it as a same test option as well. I don't feel strongly about it. So if you do feel strongly about it, I'll.
Yeah, I'm
No.
fine with a one or the other, but both. I mean, I
Alright.
definitely want one or the other. I don't.
Yeah, I
want
understand.
both.
I understand. Well, I mean, it would be more commonly unique elements by to have. I don't care that much. Put it in as a second argument. It's fine. It's like sort.
Yes, that was sort and tally and others were the model there. Symmetric difference, because it wasn't clear whether it should be var args or not. I did not implement it as the same test option, but I'll make that change.
Okay. All right, good.
Nick, if I
Yep.
could interject something,
Mhm.
it would be nice if we could move on to delete elements next, because those are all in one pull request.
Okay. Yep.
Okay.
That's fine. So this was another function we talked about with unique elements and symmetric difference. We basically get, for the list case, it's basically complement, but it works on arbitrary heads. And there's also a multiplicity option.
What's the option?
Or not option, but if you look at the subsection on counts below.
A capability.
Capability. So those.
I think no with this delete elements with the bare element.
Okay.
I think. Anybody else?
so-
Christopher, anybody else got an opinion about that? Go ahead.
Okay, well, so I missed what exactly this delete element is, but my first question is, why is this not delete cases? And two, what's this rule thing?
So the
Yeah,
rule
you
thing is
missed that,
specifying
those discussions.
Yeah.
The rule thing is a count. How many of them should you delete? I'm sorry, what was your other question, Itai?
Why is this not delete cases? And
It's giving, it's more of a literal version of that. And
Well, can you do it with
it has-
patterns?
No,
Can
it
you do it
doesn't
with
take
patterns?
patterns, and I'm not going to get into that craziness of exclusivity. Where a pattern, different, you're told to delete the same thing in two different places.
Well, you mean unification of patterns or something? Or what do you mean?
Yeah. I mean, that I think well, first of all, that would throw any efficiency out the door. Second, at that point, you might as well be using delete cases. I mean,
Sure.
So is that its
Yes.
main reason for existing? Is this significantly more efficient than delete cases of alternatives?
It's a good question. I haven't tested it timing wise. I suppose it could be, but I don't know for sure.
All
This
right,
does
so-
have the advantage, though, of allowing for multiplicities, which is
Okay.
a little trickier I think a lot trickier with
Very
delete
much
cases.
trickier with delete cases. In fact, I think impossible with delete cases.
Probably
my
not.
And wait, just to clarify also, because someone earlier said that this was like complement in the list case, this does not sort and
Correct.
delete duplicates, right?
It's not.
Okay.
Correct. This was intended partly as a non-sorted complement,
Okay.
but with the added business of multiplicities. Complement doesn't take patterns.
Right.
No,
Why
it
should it?
doesn't. No, it
and-
doesn't.
So
Wait,
why should
hold on.
this?
What?
Well, complement
Right.
is a set operation, which I guess this is like it's a list operation instead of a set operation. But is this also var args like complement?
No, because your list, it's just two arguments.
Okay.
Because you have a list and then you have the things you're deleting from it, the specification for those things.
But complement has a universal set followed by any number of sets that can be deleted from the universal set.
True, but that just, I mean, that doesn't really make sense in this context. Your universe, so to speak, is the first argument.
I'm sorry, the universe in complement is also the first argument.
That's true. I'm not sure I see much point to.
I'm not sure I see much point either.
Making this var arg. I mean,
Yeah,
I
you
was
might as well
never
just-
sure about that case either. I guess it was just union, it makes sense. Intersection, it makes sense.
I think it was
to have
just
var
some-
arg. So complement, we kind of did it as a courtesy, but
Yeah, I agree.
It's
I agree.
not
I don't think it's
unambiguously clear that it should be the first set as the universe.
right. Okay,
It's a
so
convention.
okay, so we understand what this is, and I think it's sensible, and I like the fact that it's like it is like delete cases of alternatives in the simplest case. Okay, let's look at multiplicity now. Okay, and Sandra is commenting it's for level 1 only. Yes, this is a level 1 only, right, guys? This is not. This is like a set operation.
Correct. It's
like
level
some
1
kind of-
only.
Does it have an operator form?
I don't think so. But again, I would defer to the implementation over my memory.
It should have an operator form. That seems useful to me.
Presumably the second argument.
Definitely.
Yeah.
Yes.
Okay.
Okay, let's look at the multiplicity stuff. Okay. This multiplicity is scary because of the fact that, what happens if you want to delete a list, a rule, right? The fact that we're putting
Yeah.
multiplicity into that argument is unfortunate. It would be much nicer to somehow put the multiplicity outside of that list so that, to my mind, like this case here is nice and unambiguous. Whether that's the right way around for multiplicity is a different question, but that's nice and unambiguous.
Wait, why is that unambiguous?
It's still a rule.
Oh, I'm sorry. I wasn't reading it properly. What I thought that was something like this, which would mean I would assume I would imagine we've got this, which is delete elements 2 of those, and then delete elements up to 2 of those. What if I say delete? Well, okay, hold on.
It's an implied up to.
Okay, fine. If I say delete something and it isn't there, it just says, oh, it wasn't there. There's nothing to do, right? It's not complaining.
Yes, except it doesn't say anything in the sense of no message.
Yeah, I understand.
Yeah.
Okay, so this says delete up to 2 of these. So this is equivalent to, that particular form I've got there is just join of that comma the thing itself, comma the thing again. And it will just, because it doesn't matter what the order of the second arguments, the order of the elements in the second list is, right?
Right.
There could be a third argument with specification. For example, we could have just a single 3, and then it deletes up to 3 of any of them.
No, I understand, but we also got to have the problem is, this reminds me of random choice and things like this, where, in random choice, we have,
right, but it's worse than random choice because, you can give the multiplicities. I could say you can only delete 2 A's, or I could say you can delete 2 A or B's. Right, where the sum of the number of A's deleted plus the number of B's deleted equals 2. I assume that's what that other notation is for.
No, it was meant as a sort of a listability. 2 goes to D comma B. Yeah, and I think it would be harder to do what you're suggesting, Christopher.
Okay, I was guessing that that's what that notation meant, but
Oh, no.
Sure. Okay.
Well, so
I'm not sure how useful that is anyway. But
this all raises the question of, with patterns in delete cases, for example, could there be in the world of the future a pattern wrapper that means use this pattern, up to twice, for example? In a sense, repeated already is that, but delete cases, I don't think supports that.
No, but like in the context of, no, because each time with repeated, you're doing one pattern match. With delete cases, you're doing many. And I feel like with things like accept and so on, it's going to become very meaningless.
Yeah, okay. But what you're saying is, in order to delete up to 2 of something, we don't have a mechanism to delete up to 2 of.
Right. Obviously you could roll your own, right? You could embed a counter into the pattern, and that basically the condition will fail once it's reached a limit. But there's no built-in way to do that. Of course, but the thing that's still we haven't addressed is, suppose your list is a list of rules and you want to delete one of the elements. I don't see how you can do that using this function, and maybe the answer is, by the way,
Nick.
Itai, I think it's perfectly unambiguous unless the left-hand side is a list of integers or a single integer. It's still an issue, of course, but it's not as common an issue as you might think.
So Nick, who's here, just makes this point, that in principle, you can use repeated as a counter with subset replace. For what it's worth. And definitely when we document delete elements, we should point out that the relation to nothing. I mean, this is not a trivial, right. Okay, let's, in the effort to move through this, the delete elements case without multiplicity is fairly straightforward. I think we kind of agree on that case. Question is how to introduce multiplicity.
I should mention that I did work from the spec that was, okayed in the relevant meeting.
Well,
not saying we can't change it.
That's a good argument. That's a good argument.
I'm just saying that's where this came from. I didn't make it up.
Well,
it kind of seems like the random choice like syntax would be less ambiguous. I mean, it just seems like a shame. I mean, if part of the point of this function is that unlike something like delete cases, it's very, and more like the set functions, it's very literal in the arguments. It seems like a shame if it then just treats rules with integers on the left as something totally different.
Yeah, I kind of agree. I mean, did we, in the original spec, did we consider all these cases or not? Or did we only consider the basic case?
Not sure what you're asking.
Did we talk about this multiplicity thing when we did the spec?
Yeah, that's where I got this. This rule-based spec was from the original. What was discussed in the meeting. I actually had to replay that section 2 or 3 times.
That's not a good sign.
Well, the first time I wasn't paying enough attention, I will confess.
Okay, fair enough. I really think that this is a mistake to put it inside. I think it's just going to lead to some bizarre bug at some point where somebody thinks they're deleting elements and it so happens that they fall into the trap, this random little sort of, gotcha trap of a thing that happens to have that form.
I think it's not even a random gotcha. It's like you're doing graphs and you're trying to take the complement of a list of edges and your vertices are integers.
Yeah, it's just going to be hopeless then. Right. So I think it should be like random choice.
What does like random choice mean?
Well, it means that there's an outside vector here that says, in this case, this would be 1, 2, 2, arrow.
It's unthreaded.
Yeah. That's what.
Well, I mean, it's threaded, but they're of equal size.
Right. It is post-threaded, so to speak. It is threaded in its operation. It threads to operate.
If you run thread on that, you'll get the old spec.
Yes.
Yeah. So it's an implicit. I'm fine with that change. Might simplify things. Certainly seems like it'll simplify documentation.
Actually, can I make
if we should reverse that?
Well, that's the random choice way of doing it, but I believe random choice also has an association way of doing it, which I could imagine being useful here as well, which is this case. Since delete cases necessarily has only one of each thing meaningfully listed, see, we could support this case as well. Could we not?
But again,
and by the way, does random choice support that? I thought it did.
Not documented.
But it does, doesn't it?
So if your list has those rules, A goes to 1 inside DE list, then we have, I see, but you have to
just ignore it. This is not.
Random choice just takes the random choice of the values. I think is what it actually does.
Yeah, Stephen, I think you're going to remove a lot of ambiguity if you go with the 1, 2, 2 goes to ABDB and don't allow that threaded version.
I agree.
Explicitly threaded.
Yeah. That's what I'm suggesting.
Okay.
I'm suggesting.
But no, you're suggesting an association form also.
Well, I'm not suggesting that all that seriously.
Okay.
My remaining question is, do we have the order the way we want it, or should it be the other order? ADB goes to 1, 2, 2.
No, it should be this way around, to be the same as random choice, in my opinion.
Choice. I thought
Takes
random
weights.
choice.
Weights and the values.
Oh, yes. Okay. Interesting. Yeah. Okay. So
Right.
I'll do that.
Okay, then the other case that you probably should support is naked number goes to that. Means up to 2 of each of them.
Can it like support the similar syntax to delimiters? Like if you want multiplicity of the first elements and then some repeated and the last one different multiplicity, something like that.
You mean to put something in here that is sublists of some kind?
Yeah, different sublists.
Right, so this is so that you can do the thing of saying that you want the number of A's deleted plus the number of B's deleted to be less than 2.
Wait a minute, is this?
Or maybe if I have like a list that specifies that the last element should be repeated twice, but every other element once. So it would be just list of 1, 2. So it's 1 repeated.
How do you know it's not going to be 1 and then a bunch of 2s, but it's instead going to be a bunch of 1s and then a 2?
Well, the same way as you have for the grids, the delimiters syntax.
Right, so they're just
not
default
outlined
always
now.
pads to the left,
Yeah.
basically. Okay.
I do not believe we should compound the issue with grids. We're just trying to climb out of the grids problem. Let's not compound it here, at least for right now. And it's not incompatible with what we could add that subsequently if we wanted to. Random choice does not appear to do anything terribly useful in this case.
Yeah, it just does random choice of values.
Where's the A?
Oh no, the A disappeared because it has the same key as B.
Oh. Utterly obscure. But so it doesn't do key. I mean, that's something we should discuss for random choice itself, because the reason I'm saying that is because
The more common cases, you have values, arrow, weights in the association.
yeah, that's what I'm saying. That this case here, where that's not doing it correctly.
There's also weighted data.
Weighted data, yeah, I agree. That's a different way of doing it. But the thing is that there are machine learning functions that accept these 2 cases. That is, classify, for example, accepts these 2 cases, I believe. We need to look at that. That's more of an LCC type thing, to look at consistency between random choice associations and machine learning association usage. Can we add that? We need to move on now. But I think we've got a solution for delete elements for right now.
Quick question. Will we allow a single list without a rule as an implicit 1 goes to?
Of course.
Okay.
No,
fine.
I thought it would be infinity goes to.
Oh, yes, it is.
I'm fine with that. That's a good point. That's probably the more straightforward in terms of what someone would expect.
Okay, and then just a naked thing is an implicit infinity goes to list of that singleton.
That is correct.
Yes.
You should probably support the infinity case just because so you can write 1, infinity, whatever.
Well, hold on. Maybe
Okay.
we shouldn't support the naked case though, like delete elements of list A, because then
Oh
it's
no, we shouldn't
ambiguous
support
if A
that
is a
case.
rule.
We should not support that case. We should support only a list in the second argument, a list or rule in the second argument. But the point is that the first element of the rule could be a naked 2, for example.
Yeah.
Okay, all right. So list or rule, and if it's a rule, then there can be an implicit list on both sides, or they have to be matched.
No. They have to be no. On the okay. The one case we're not covering here is okay. This is okay, and this is okay. All right. So the case that will be a little weird is this case here. What does this case here mean? I'm perfectly happy with making an error for the time being.
Yeah, I don't like that at all.
Fine, so let's make it an error for now.
Okay,
Yeah,
so
I'm fine
2
with that.
goes, is 2 goes to A also verboten, or is
Yes,
that,
that's not allowed.
okay,
But I think that this case here is equivalent, that case we understand, right? And the
Right,
default case
yes.
of just ADB would be infinity arrow ADB, correct?
Yes.
okay. All right, now I'm convinced we have something consistent and sensible.
Okay, fine, good. All right, let's move on. Ethan is asking on our live stream an utterly irrelevant question about command line deploy. I just want to say that we have some really, really terrific stuff coming there. It's coming together extremely well, and we'll at some point have a live stream about it. But that is, expect good things for standalone deployment. Really nice. Rather excited about that, actually. It's a complicated but successful piece of software engineering. Okay, let's continue here with position largest, smallest. Although I do want to scope this out because we're going to run out of time, and I think supplied is probably one of our more important things to discuss, unless we think, I mean, in I'm not totally happy.
Why is this here? I mean, we were going to discuss that next week in the
Yeah, I
LCC
mean,
with the
supply-
largest seating.
Yeah.
Okay, fine. So why is it here? Is this the wrong meeting for this?
That was going to be an extra topic if we burned.
Wanted
through
to pad out the time. Okay,
Yeah.
no padding.
Don't think we'll need that.
Okay, let's go back here. Okay, let's talk about what the heck is this?
So this is related to the discussion of position largest, position smallest. It is the idea in the current implementation of position largest that Danny has put together. The second argument is a rank specification. So position largest, comma 1 means give me the position of all of the largest elements. Position largest 2 is not give me 2 elements. It is give me the position of the 2 largest elements, regardless of multiplicity. And we had talked previously about that being a useful thing to do, but needing some way to indicate the difference between rank versus instances if we want to have a rank notation for things like take largest, take smallest, position largest, ranked max, etc.
Well, my first comment is that I think this should be like ranked or something like that.
Yeah. The name
Yeah.
is wrong, but I
Right,
mean,
just to be clear, this has nothing to do with the rank of a tensor.
Or,
Right.
or of a matrix.
yeah, right. It's a matrix rank. Yes, it's but what this is, I mean,
Can it be just up to?
no,
I think it
because
means
it's
something
no.
different.
thing. Because what it means is, well,
Yeah,
in take
we
largest.
really
it
need a
could be.
concrete example there so people can see the difference. Otherwise, it's too confusing. Can
Right. So
we?
if you open the subsection on multiplicity and rank in position largest and smallest, there's a few examples and a question about how we would handle output.
Yeah, hold on. Position smallest. What the heck does that mean? Why is that 2
Find the
elements?
positions of all elements that are either the smallest or second smallest.
Oh, I
In
see.
this case, the smallest are 0 and 1 at the 2 smallest.
That's different from take smallest arrow
Yeah.
index, because in take smallest arrow index, if you said 2, it can only give you 2 things.
Right.
Right.
That was actually the main point of these position functions, because otherwise we would use the take smallest with the arrow index.
Okay, so take smallest. I'm sorry. Okay, so just to be clear, to put this in context, take smallest here is just that. Okay.
Correct.
Okay, so position smallest is of the smallest 2 ranked things. Where are they? right? So of the smallest rank thing, it's there. Okay.
Right. And I don't like the asymmetry in that position smallest and take smallest have a second argument that's an integer and give different results. And we generally agreed that this notion of being able to pull out a ranked element is potentially useful, not just in the position functions, but in the other functions. But we need a headdress or some notation that's descriptive.
Well, I don't know what would it when it loses its headdress and is going around. I don't know what the right analogy is, but
undecorated.
Yeah, undecorated. What does it mean then in position smallest?
Then it would potentially be the same thing as take smallest, but that's not nearly as useful.
Not that. I don't think that's look. Okay. The issue is you're saying take smallest, that second argument is again a rank, is it not?
In take smallest, it's a count. It is the nth number of smallest elements, regardless of multiplicity.
So why exactly? I mean, isn't it just that one function uses rank and the other function uses count? Why do we need to have a special monad for that?
Well, that's the way we were looking at doing it for the position functions, and the discussion last time we looked at that was, oh, it might be useful to have the same functionality in take largest or nearest or whatever else we have that, or ranked max, ranked min, some notion of referring to the rank in the ordering.
Well, but then we're going to retrofit. I should mention that, Nick, particularly for nearest. It's a very difficult implementation, I think.
Right. And then we're going to end up with rank, and then we're going to have whatever the opposite of rank is, count, which obviously can't, is taken. We're going to have rank and count, and then you're going to have to know this function defaults to count and this function defaults to rank, and they're equivalent to each other if you use the wrappers.
Okay, let me try and understand this again. Position smallest in its first approximation is give me the position. Why do we want that to be rank, not count, in position smallest?
We wanted it because we're going to immediately run into multiplicity questions when we say, give me the position of the largest element in this list, and there's multiple instances of it. And so we wanted...
So like commonest, for example, which always returns a list.
Exactly. And so we said, do we want a second argument? What would the second argument mean? Having it just truncate the list down to a length 1 regardless of multiplicity seemed a little weird, and we said, oh, having a rank would potentially be useful to say, give me the position of the 3 largest ranks within the list.
Right, and that does seem more, because this is one of the downsides of take largest, take smallest arrow index, is that they kind of there's like the rigor of commonest is that if there's a collision, it gives you a list, but you lose that with take largest, take smallest.
Yeah, that's
what does it do? It just does the ones from the left, or what?
I think
yeah.
It might be from the left. I'm not absolutely certain, but in any case, it's
that doesn't work yet.
It's equivalent to sorting them and then taking, right?
It's rule in the first argument. So it's the least arrow index.
Oh, I see.
Yeah. I don't remember for sure. If you, for instance, were to change one of those zeros to 0 point.
Okay, this is completely bizarre to me. Why is it 213, not 123?
Or 001? Oh, no, sorry.
No, it's giving the
indices.
positions,
Yeah,
but
yeah.
that's why I was saying there's an
Yeah.
ambiguity. It's really undefined.
Obviously,
in which
right.
order.
But this is definitely, well, it's undefined unless you define it to be, for example, left to right order.
What does ordering do?
On what?
On the same list, if you say ordering of that list. The question is, does it also do the 2, 1, 3 thing?
No.
No, but I mean, if you say explicitly numerical order and make one of those a decimal, then I wonder, is it always going to be well defined in terms of, left to right breaking ties or not?
Well, I
I
mean,
don't know
yes,
the
there's a
answer.
bunch of weirdness with non-associativity of.
Well, that too, but let's assume we have an associative order. Is it, or at least that it's associative with the input in question? Is it always going to break ties left to right? I don't know.
I think it should. Okay.
I think we've gone into that territory now that I remember it.
Okay. So look, the basic question here, relevant for 13.1, is position smallest. Is it a rank or is it a count by default?
We definitely want to rank. I'm convinced of that. Otherwise, we don't get the information that we all agree we want.
Okay.
I mean, that's pretty much what we decided.
Yeah, I think I agree.
There's the question of, well, do we extend this to other functions or not? Do we have a wrapper?
I think the wrapper is really complicated.
I think it would be complicated from the implementation side, not impossible. But there are other questions about this. The current output, Jose and I guess Nick also agree, is probably not what we want. But the question is, what do we want?
Which
in other words, we're not separating the ranks.
Oh.
I mean, if you did separate the ranks, the sad thing is that then you'd have it so that with one argument, right? You'd like it
double lists with one argument, which is horrifying.
Right.
I mean,
that's
like
annoying.
A list of lists is the correct thing, but
I mean, right now with one argument, what does it do? It produces a list, presumably.
Yep.
Yeah, same as with 2 arguments. It's didn't implement. No,
it should give a list. It should be the same as (1).
Yeah. Okay. So.
Okay, but let's go back on this for a second. I mean, so position, for example, has this feature that it gives a list of lists, right? Unless I'm not going completely crazy because I didn't have my lunch yet. Let's see. Oops, position I meant. Yeah, so that gives a list of lists. So position smallest would be within its rights to give something which has the same structure as the results from position. Am I making sense? I mean, okay, so here's a bizarre idea. Maybe this is wrong. What about a position by? Is that obviously stupid? That's not quite the right thing because it has to ingest the whole. That won't work because it's got to sort everything, right? That's stupid. Never mind. Is there an analog of that might work?
Well, I mean, presumably you can give an ordering function to position smallest. But
yes.
What we allow now, we have a position smallest by, but other than that, what we allow is a comparison function as an optional argument.
Okay, what I'm thinking is
an ordering function. So it returns -1, 0, or 1.
horrifying, but yes.
Yeah, it's horrifying, but it's also used elsewhere.
Right. Okay, so what I'm thinking is position smallest should have the same return structure as position.
So it should be giving position specs rather than part specs.
I think so. If it gives position specs, then we're completely unambiguous in terms of this whole business about, then everything will just work.
Wait, hold on. But the position returns a list of positions, though. Do you mean position or first position?
Yeah, I'm not sure that this is exactly analogous. I favor the idea of giving a list of lists.
Yeah, but you think the outer list represents the ranking, not.
Yes, the position in the outer list represents the ranking. Lowercase p position.
Yeah, I understand.
Also, it doesn't make sense to give position specs as opposed to part specs if there's no level spec, because it'll always be length 1 lists.
Okay, fair point. Okay, so there's no point in doing the inner list, which in the case of position, so it will be a list of lists, but the meaning of the outer list is different from the meaning. No, the meaning of the outer list is the same. No. The meaning of the list.
It's a totally different set of lists from position, I think.
Yes.
The
only thing in common is that they're all lists.
Yes.
Okay, so then what it is a list of the smallest ranked, the positions of the smallest ranked things, the next smallest ranked things, and so on.
Yes.
It really, well, okay. I mean, but so, I don't know. It seems much more useful if it just gives you the first list without an extra level of list around it by default. I mean, part of the advantage of, that's why we have functions like first position is because it's annoying to say part 1.
Yeah, I know.
Christopher, I agree with that, but we lose information if we don't do this. We are withholding valuable information that we actually had during the computation.
Okay,
right.
So here's
that's only if we care about the 2-argument case. I mean, if the point of the 2-argument case, like, I don't know, maybe the 2-argument case is legitimately useful. But maybe it's also if the 2-argument case is basically here because we thought, well, okay, if it has a second argument, what is it? And this is the answer. I feel like then that may not be as good a reason to make it less convenient.
The problem is that for many people, there will be a unique smallest, and then they get back a list, even in the case where there's no second argument. And that's already confusing.
That's the same as commonest, though.
I know it's the same as commonest.
Perhaps the problem here is that we are asking this multiplicity to the wrong function. So this is more like a tally largest. So perhaps this is something that goes with tally more than take or position.
When we have a second argument and it's not 1, then we initially have, during the computation, we have the rank information of who belongs to which rank. But we don't currently give that information. And I kind of think that might be information people will want.
I think we don't have this figured out. Look, the problem is the very minimal case, position smallest, I just want one number, 17, the position of the smallest thing. That's a common case.
By the way, one danger maybe to point out is that if it returns a list of all the ties of the smallest ones, and most of the time, there's no collision, it'll get back position smallest, and it'll be back list 17. People might think that's a position spec, like what first position returns, and then use it in like extract or something like that. But it's not a position spec. It's a list of part specs. So if there was a collision, they'd suddenly get a length 3 list, which breaks extract.
Yes.
But I still think the part of the reason for wanting these functions was to handle a rank. And so we want to give that information. Once in a while, you have to tell people, look, check the documentation. We're returning this
Yeah,
result.
but
in
if
this
every
form for
single
a
time the
reason.
function is used, it's full of first of, part 1, 1, that's not good.
It's not dreadful.
It's not good. I mean, if only one time in 1,000 you want to use the other case, it's not good to have to, mess up your code with that thing. And that's why we introduced first position.
But why not just have the, I mean, you get rid of at least one of those using the take smallest goes to index.
I know, but that's also pretty ugly. I think we need to wrap this meeting. And I'm not to be continued. I don't think we've resolved this. And a rush decision is going to be wrong.
Okay, we'll circle back to this next time.
Yeah, I think so. Sorry. I mean, okay, a lot of good stuff here, and we get to talk about supplied or whatever it's called in
LCC. Yep.
Okay, sounds good. All right, thanks a lot, everybody, and so.